All right, before we go further, let's review what we have seen so far. Okay. All right. Evidence number one: if you mix an alkyl halide with a new chlorophyll, you get a substitution product and a salt coming out of the reaction. All right. So the product is substitution and a salt. And kinetic evidence show that it's a second order or bimolecular reaction, suggesting that the two substrates collide. Right, there's direct collision between the two, and the stereochemistry suggests that the direction that the nucleophile approach an alkyl halide is from the opposite direction from the leaving group, and we call that a backside attack. Right, and as a result, the configuration of the product compared to the starting material is inverted. Right, so what we call inversion of a configuration. All right. From what right here, let's take a pause and talk about how do we draw an SN2 mechanism. Okay, so when you draw an SN2 mechanism, you're going to have two substrates, only these two. We're going to have an alkyl halide with a good leaving group. All right, there's a leaving group right there, and a new chlorophyll. And every time when you draw a curved arrow, we draw it from a new chlorophyll to an electrophile. Electrophilic center. So this one is backside attack, which is from opposite side of the leaving group. Leaving group on the right, we come this new chlorophyll approaches from the left. All right. Now, about to leave, we can draw a transition state that show electron distribution. I'll take a look at right here. So just want to show you a little bit. So the full charge on a new chlorophyll. Right, it's by itself. When it starts to form bond with an alkyl halide, this negative charge right here will be distributed from the new chlorophyll to carbon to an X, to a leaving group. Right, so from the full charge, the new chlorophyll become a partial charge. Right, and because all the charge are being distributed to carbon and X, and at the end, X gonna have the full charge when they come out. Right, so bond forming on the left side, bond breaking on the right side. Right, and X come out. All right. When you draw an SN2 reaction mechanism, you don't need to show a transition state unless I ask you to. You can just go from here and go all the way to the right to the product. All right. I'll give you some example here. All right. So let's say draw an SN2 reaction mechanism. So this is your new chlorophyll, this is your electrophile. So bromine, which is a leaving group, is pointed to the right, which means that the new chlorophyll have to come from the left side right there. All right, a little bit about electrophile. So high electronegativity of bromine is partially negative. So that makes carbon partially positive. So the negative go to positive there. Okay, when you draw it, you have to go from the opposite side of the leaving group, or we call it backside attack. And then bromine leaves, and you get the product where all the three group right here got pushed to the other side. That's a full mechanism of it with the detail. All right. Okay, now let's do on your own. Okay, draw the curved arrow and show the product of this SN2 reaction, and then you check with me. So we have the new chlorophyll here for sure, and a sulfide S minus, right? And your electrophilic center is carbon because it's connected to chlorine. Chlorine is a highly electronegative atom, partial negative. So carbon partial positive. That's your electrophilic center. All right, so negative go to positive, so we'll attack that carbon for sure. Now, how do you draw the product? Well, chlorine right now is on a wedge line, which means point up to your face, right? Point up. So which means that sulfide have to approach from the backside, from pointing down. Okay, from the back of the molecule. So you're gonna have sulfide on a dashed line coming from the backside of the leaving group. All right. Now this one is opposite side. So chloride is your new chlorophyll, and iodide, that's a leaving group bonded to carbon. So carbon is going to be partial positive. That's your electrophilic center. All right. Now chloride going to attack carbon for sure. But look at the direction though. Iodide is point away from you on a wedge line, point away from you, which means that chlorine have to come from your face, come down, right from the front. The chloride going to be on a wedge line. All right. All right. Now this time, watch out though. So bromine is not on wedge or dash; it's on the paper plane. All right. We get back to that. All right. So your new chlorophyll is a hydroxide ion. Right here. The carbon is the partial positive. This your electrophilic center. So the hydroxide ion gonna attack that carbon for sure. Right. But now, from which direction though? Well, bromine pointing up. So hydroxide ion have to come from the bottom from down, right? And when you draw it, so hydroxide ion gonna be on not wedge or dash, gonna be just the line on a paper plane, but point down. That make methyl and hydrogen point up, push everything upward, look like that. Okay, so that's how you look at the molecule as a 3D structure, and it takes some practice, but I think you'll get a hang of it soon. Okay, all right, let's see what we got. We have a class activity number 1. Oh, by the way, so this is our configuration. You're gonna get an S configuration. You can determine on your own. Let's try that. All right. We have a class activity. So we have class activity 1 and 1, 2, 3. Yep. Okay. Now I have a partial key right here. Right. Number 3, I asked you to draw a transition state for each SN2 reaction. That's the answer. Try draw it by yourself first. Don't just look at the answer right away. Okay. All right. Let's moving on to evidence number 3. Next video.